Alright, so this video we're going to look at product and quotient rule for derivatives. So first let's look at the rules. We've got the product rule here first. It says, so if f and g are both differentiable, then the derivative of f times g, so we got two functions multiplied to each other. So f is the first function, g is the second function. So the derivative is f prime times g plus g prime times f. So the way I usually remember it and say it is, so you got your first function, you got your second function. So it's the derivative of the first function times the second function plus the derivative of the second function times the first function. So it's derivative of first times second plus derivative of second times first. And then we've got the quotient rule, so f and g are both differentiable, and we got f over g. So it's f prime times g minus g prime times f over g squared. So basically what it is, it's the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator, and all that is over the denominator squared. So in order to do this, you've got to remember those rules. All right, so here's a couple of more rules added. The rule that you learned in the previous video, or if you didn't watch the previous video in the section before this one, you learned the power rule, the derivative of x to the n. All right, and I'll just go ahead and write that down. So you got the derivative of x to the n. Remember, that's n times x to the n minus 1. So these are the three rules that you have so far for finding derivatives. Okay, you've got to know these. You've got to remember them. All right, so let's work some examples. I got quite a few examples. Some product rules, some quotient rule, and then we'll do some other things like find an equation of tangent line, that good stuff. All right, so let's look at this. So let's find the derivative. So here's the first function, x squared plus 3. Our second function is 2x minus 7. We want to find the derivative. So we've got f prime of x. So remember, the product rule is the derivative of the first function. So that's 2x. The derivative of x squared plus 3. Derivative of x squared is 2x. Derivative of 3 is 0. So this is the derivative of the first function times the second function, 2x minus 7, plus the derivative of the second function. So the derivative of 2x is 2, derivative minus 7 is 0. So this is the derivative of the second function, and then times the first, x squared plus 3. And then all we do is we just clear the parentheses and combine like terms. So I got f prime of x is 4x squared minus 14x plus 2x squared plus 6. So f prime of x is, 6x squared minus 14x plus 6. And there's your answer. All right, so I used the product rule there. Now, let's look at this, and I'm just going to do it on this problem just to show you. But we could also write f of x as, 2x cubed minus 7x squared plus 6x minus 21. So all I did is I just fold this out, okay, multiplied it out. I just take the derivative of this. So f prime of x, so that's going to be 6x squared minus 14x plus 6. And see, you get the same exact answer. All right. So which way should you do it? Well, it doesn't matter. They're both correct. But what I would recommend, if you're in this section here in your class and you come across something like this, I would not, for right now, I would not multiply it out like this and then take the derivative. I would do the product rule. so you can get practice using the product rule. Okay, just practice the product rule as much as you can, because you know you're going to come across some problems later on, maybe not this section, but definitely later on, where you're not going to have any choice but to use the product rule. So you got to learn how to use it. All right, let's look at the next example. So here's our first function, here's our second function. So let's see what we get. So we get f prime of x. So the derivative of the first function, that's 2x, times the second function, x squared plus 2x minus 4, plus the derivative of the second function. So that's going to be 2x plus 2. All right, derivative x squared is 2x, derivative of 2x is 2, derivative minus 4 is 0. So that's the derivative of the second function times the first function, x squared plus 5. And then we just got to multiply these out, combine like terms. So I get f prime of x is equal to 2x cubed plus 4x squared minus 8x plus, and then I got to fold this out, or let's see, that's going to be plus 2x cubed plus 10x plus 2x squared plus 10. And so f prime of x, let's see, that's going to be what, 4x cubed. Let me mark these out as I add them so I don't miss anything. And so 4x squared plus 2x squared is 6x squared. Let's mark those out. And then I've got negative 8x plus 10x is 2x. So those are gone. And then plus 10. All right. And there's your answer. So hopefully I didn't make any careless mistakes in there when I was multiplying that out. It can get all jumbled up. All right, so how about this one? Another product rule. So my first function is x squared. My second function is e to the x. So I've got f prime x is the derivative of the first function, which is 2x, times the second function, plus the derivative of the second function. Well, what's the derivative of e to the x? Remember, derivative of e to the x is just e to the x times the first function. All right, so this 2x, that's the derivative of the first function times the second function, plus the derivative of the second function times the first function. And then what I would do here is I would write this as f prime of x, and let's factor out that common factor of e to the x, and that leaves us with let's factor out the common factor x, e to the x, and that's going to leave me with 2 plus x, and there's your answer. All right, I would go ahead and, anytime you got that common factor of e to a power, go ahead and factor that thing out. All right, and I guess one of the reasons that you want to do that, or kind of get used to factoring out that e to the x, is sometimes when we take these derivatives, we want to set them equal to 0 and solve for x. So so just go ahead and factor out that greatest common factor there. All right, let's look at the next one. All right, so I've got f of x equals the square root of x times a plus b to the x. Now, in this problem, you've got to understand that our variable is x. This is a function in terms of x. A and b, you treat those like numbers. Those are constants. All right. So the first thing I'm going to do is I'm going to change that square root of x to x to the 1/2. All right. Now, I'll say this, in this problem, it would be a lot easier just to distribute that x to the 1/2 and clear those parentheses. That would be a lot easier to take the derivative. But let's go ahead and let's do the product rule. Okay. Now, if I were just working this and I wasn't showing you how to do product and quotient rule, and I was just working this problem, I would probably distribute the x to the 1/2, clear those parentheses, and then take the derivative. Okay, but we're going to do product rule. And in a later video, I think the video I do on the chain rule, if you watch that video, I'll show you an easy way to take the derivative of a square root, where you don't have to rewrite it as x to the 1/2. And if you don't want to watch that video, you can go to my channel and search for shortcut for taking the derivative of a square root. Just search for that video on my YouTube channel, and I show you a shortcut there. It's a lot easier. All right, so let's take the derivative. So I get f prime of x is equal to the derivative of the first function. So that's going to be 1/2 x to the negative 1/2. So the 1/2 comes down. Subtract 1 from the exponent. So this is the derivative of the first function. And then I've got times the second function. Right? And then that's plus the derivative of the second function. Well, what's the derivative of a plus bx? Well, the derivative of a is 0. The derivative of bx is just b. See that? Is b. Remember, the derivative of 5x is 5. The derivative of 7x is 7. The derivative of bx is b. And so that's the derivative of the second function times the first function. And so this is going to give me f prime of x is equal to a plus bx over 2 square root of x plus b square root of x. I just changed the 1/2 powers to square root back to square root of x. Remember this right here, that negative exponent. So I move it down into the denominator with the 2, and that changes it to x to the 1/2. All right, so let me just come over here. So what it would look like, the step before this one, is I would write this a plus bx over 2x to the positive 1/2 plus bx to the 1/2, and then change those 1/2 powers to square roots. All right, I just skipped this step right here. All right, so hopefully all this is making sense to you. I mean, product rule, it's not hard to do. You just gotta follow those rules. All right, so here we've got the quotient rule. All right, so let's look at this, the quotient rule. So the derivative, so remember, the quotient rule is the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator, all that over the denominator squared. All right, so the derivative of the numerator, which that's going to be 2x plus 1, that's the derivative of the numerator, times the denominator, x cubed plus 6, minus the derivative of the denominator, which is 3x squared, times the numerator, x squared plus x minus 2. And that's all over the denominator squared. All right, so don't get messed up on this quotient rule. Students miss this all the time. They get the numerator wrong. They'll take the derivative of the denominator first and multiply it times the numerator. They always do that. Just remember, it's the derivative of the the derivative of the numerator first times the denominator minus, and then it's the derivative of the denominator. Just remember, you take the derivative numerator first. Just remember, it's on the top, so you do it first. And then we've got to multiply this out, combine like terms. So here that's going to be 2x to the fourth plus 12x plus x cubed plus 6 minus 3x to the fourth minus 3x cubed minus 6x squared over x cubed plus 6 squared. And then let's combine like terms. So that's going to be negative x to the fourth. Let me cross these out as I'm doing them. And then x cubed minus 3x cubed, that's minus 2x cubed. So minus 2x cubed. And then I've got no more like terms. And then that's minus 6x squared plus 12x plus 6 over x cubed plus 6 squared. All right, so I mean, not difficult to do, just, you know, a little more involved on simplifying it out, multiplying this out, combining like terms, but still it's not hard. It's algebra. Okay. All right, so how about this one? So we got y equals the square root of x over 2 plus x. All right, so first thing I want to do here is let's change this to x to the 1/2 over 2 plus x. All right, write the square root as x to the 1/2 power. So I'm going to get y prime is the derivative of the numerator, which that's going to be 1/2 x to the negative 1/2 times the denominator, all right, minus the derivative of the denominator, which is 1, times the numerator, and this is all over the denominator squared. All right, so now let's look at simplifying this thing. So this is going to be 2 plus x over 2 square root of x minus square root of x over 2 plus x squared. All right, so do you leave it like that? I probably wouldn't. I would simplify it. So how do we simplify this thing? Well, look at this as a complex fraction. It's all that over 1. So I'm going to get a common denominator of the 2 square root of x, the 1 and the 1, and that common denominator is 2 square root of x. And I'm going to multiply 2 square root of x to each term. And so this is going to give me 2 plus x minus, and then this times this, that's going to be 2x over 2 square root of x times 2 plus x squared. And so this is going to leave me with 2 minus x over 2 square root of x times 2 plus x squared. And there's your derivative. All right, so, you know, all that is, it's simplifying a complex fraction. All right, another one. All right, so once again, we've got quotient rule. So I've got y prime, derivative of the numerator, which is 1, times the denominator, minus the derivative of the denominator, which is e to the x, times the numerator. And that's all over the denominator squared. All right. And so now let's let's distribute, combine like terms. So I'm going to get 1 plus e to the x minus e to the x minus x e to the x over 1 plus e to the x squared. All right. All right, so now we've got, well, look at there. See these e to the x's here? Those go to 0, so I'm left with 1 minus x e to the x over 1 plus e to the x squared. And, well, looks like that's about it. That's about all you're going to be able to do with that one. All right, so everything's going good so far, I hope. I hope you're understanding. It's just following the formulas. I'm telling you, on this, the most difficult part is going to be the algebra in it, simplifying your answer. All right, how about this one? Well, let's see. So I've got y prime is equal to, so I've got quotient rule. So the derivative of the numerator times the denominator minus the derivative of the denominator, which is 3x squared plus 4x, times 1 times the numerator. So that's x cubed plus 2x squared minus 1, and then all that squared. So this is nice. This right here, this goes to 0. And so I get y prime is equal to negative 3x squared plus 4x over x cubed plus 2x squared minus 1 squared. And then, I mean, do you need to do this? I don't know. You can leave it like this, or you can distribute the negative, whatever you want to do. And so there's your answer. Now, in another video, this problem right here, there's actually another way that you can do it that it's I guess you could say it's a little easier, I guess. I don't know. Maybe a little bit easier. You don't have to do the quotient rule on this one. All right. And actually on this one, you don't have to do quotient rule either. You'll learn that when we get into chain rule. But as far as this one, I think the quotient rule is easier to do than chain rule. But on this one, doing chain rule on that one would probably be easier than quotient rule. But like I said, that's the, I don't know if it's going to be the next video, but maybe the one after that. Just look for the one on chain rule. All right, so let's look at this one. So for this problem, now you've learned the quotient rule. So a lot of times what students will do after they learn the quotient rule is they see a fraction like this. That's the first thing that pops into their mind is quotient rule. Okay, that's the first thing. Just because it's a fraction doesn't mean you have to do the quotient rule. So first thing I'm going to do is I'm going to rewrite this as 3x squared plus 2x to the 1/2 over x. All right, just change the square root to x to the 1/2, just like we've done on all the other problems. Now, I'm still not going to take the derivative. So let's get this f of x, that's 3x squared over x plus 2x to the 1/2 over x. Okay, I split it up. And so now I get f of x is equal to 3x plus 2x to the negative 1/2. So remember, when you have like bases and you're dividing, you subtract the exponents. So remember, this is x to the 1, so that's 1/2 minus 1, negative 1/2. And now look at this. Now you can use power rule. So that's 3 minus x to the negative 3/2, right? See, the negative 1/2 times 2 is negative 1. Subtract 1, negative 1/2 minus 1 is negative 3/2. And so then I get f prime of x is equal to 3 minus 1 over x to the 3/2. And there's your answer. All right. So just remember that because you have a quotient, that doesn't necessarily mean you have to use the quotient rule. If you can split it up like that, do that. Now, would the quotient rule work on this one? Yeah, it would work. Okay. All right, so let's look at this one. We got 2 more to do. All right, so we've got f of x is equal to x to the 1/2 times g of x. All right. Now, what they want us to do is they want us to find f prime of 4. So we want to take the derivative of this and then evaluate the derivative at 4. But notice they don't tell us what g of x is. They just say this is g of x. But they do tell us what g of 4 equals and what g prime of 4 equals. They do tell us that. So I've got f prime of x is equal to, all right, so that's the derivative of the first function. So that's going to be 1/2 x to the negative 1/2, right? 1/2 comes down, subtract 1. So that's the derivative of the first function times the second function, which is just g of x, plus the derivative of the second function. So that's g prime of x times the first function times x to the 1/2. And so that's going to give me f prime of x. That's going to be 1 over 2 square root of x. I just x to the negative 1/2, moved it to the denominator, changed it to a 1/2 power. And then that's times g of x plus, and then that's going to give me g prime of x times the square root of x. So there's my derivative. All right. Now, what do they want us to do? They want us to find f prime of 4. So f prime of 4 is equal to 1 over 2 square root of 4 times g of 4. All right, we're replacing all the x's with a 4 plus g prime of 4 times the square root of 4. And so this is going to give me, this is what? 1/4, the square root of 4 is 2, times g of 4. Well, let's see. G of 4 is 2, so that's times 2, plus g prime of 4 is 3, times square root of 4, which is 2. And so that's going to be what? That's 1/2 plus 6, which is 13 over 2. If I did that right in my head, I believe I did. Yeah, that's right. All right, so see, that's all it is. And all I did is I followed the product rule, that property, the product rule. That's all I did. All right, so last problem. Find an equation of the tangent line to the curve y equals e to the x over 1 plus x squared at the point 1e over 2. All right, so if you've watched the videos, or if you're at this point in calculus, if you're up to this point in calculus, you know how to work this problem. You find the equation of a tangent line. The only difference is to take the derivative, we got to use the quotient rule. So we know to find the equation of the tangent line, we got to take the derivative, then we evaluate the derivative at the point. That gives us the slope of the tangent line, and then we use the point slope form. All right, so let's do y prime. That's the derivative of the numerator, which is just e to the x, times the denominator, minus the derivative of the denominator, which is 2x, times the numerator, which is e to the x. And that's all over the denominator squared. Now, let's, do we need to simplify this out? Really, when you think about it, you don't need to simplify it out, because this is not an answer for us. Okay, we're not finding the derivative. We're finding the equation of a tangent line. So all I'm concerned about this is, what do I get when I plug 1 in for x? Okay, so let's just do that. So the slope is the derivative evaluated at 1. So that's e to the first times 1 plus 1 squared minus 2 times 1 times e to the first over 1 plus 1 squared squared. And so for the slope, so that is actually equal to 0, isn't it? See, this is 2 in here, so that's 2e minus, and that's 2e over, and that's 2 squared over 4. So our slope is 0. All right. So, well, that's nice there. That makes it a whole lot easier for us to find the equation of the tangent line. We don't even need to use the point slope form. You can use the point slope form, but we don't need to. Remember, a horizontal line. This is a horizontal line. The slope's 0. So the equation of a horizontal line is what? Y equals, right? Well, what's y? E over 2. So there's the equation of your tangent line. And look, if you use the point slope form, if you use this and plugged everything in, you would get the same thing. All right. So there it is. That's product and quotient rule. Very important, very, very important that you understand how to use this property, along with the power rule that you learned before this. You've got to know all of this to be able to take derivatives. All right. So I hope the video helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I'll see you later.